In this video, we're going to talk about the ideas and introduce the ideas of probability. This is going to be mostly definitions, but it should give you a nice overview of what the basic ideas of probability are. So let's start. The first thing that we want to do is we want to define what an event is. An event is the main thing that we're looking at, and it's the outcome of an experiment. Okay, so that's the key thing that we tend to look at when we are working with probability. Well, and what is an experiment? Well, an experiment is the process on which we go through to find an event. So it's kind of circular in the definitions. But we do in our experiment to get an outcome, and that outcome is what we are basically measuring. So that's kind of how we determine this, and we call that outcome the event. Okay? And then most of what we're going to work with are called random experiments. Now there's a couple different types of experiments, but random is really the most common one that you're going to work with when you're dealing with probability. So a random experiment is when there is some uncertainty with your outcome. So we don't know exactly what we're going to get. And we generally never know exactly what we're going to get when we're talking about probability. But this is what a random experiment is. It's when we have that uncertainty. So if we put ourselves on a continuum, let's say we've got a line of a continuous line here, or maybe not a continuous line, but we've got a line, and on that line we have impossibilities of something happen and a certainty of something happening. Somewhere right in the middle of that we've got even chance of something happening, right? So it's either impossible, it's certain, or there might be a 50-50 chance. And this spectrum goes from 0 to 1 with our even chance of being 1/2 or 0.5. Now, these are all ways to measure your event, or measure your probability, the probability of an event, I should say. So these things are anytime you're talking about these, you've got your fractions and decimals here. This is all just another way to say we've got percentages, right? So we've got 100% being certain, 0% being impossible, and a 50% chance or a 50-50 chance if it's right in the middle. Okay, and so we have a whole spectrum there. And what this means is that the probability of an event, which we usually call A or B, or maybe we'll label it as something, we'll define it like we do a variable. So if we've got the probability of an event, it's going to fall between 0 and 1. Now that's using decimals, and that's not using percentages, but obviously if you're using percentages, it would fall between 0 and 100. But every single probability that you work with should come out between 0 and 1. Okay? So there are two main types of probability. The first one is theoretical probability. And theoretical probability is when we look at the favorable outcomes, the things that we want, and we divide it by all possible outcomes from a situation. So what we do is we'll count up the number of outcomes over the number of in our sample space. This U is called a sample space. So basically that means that we're going to count up all possible outcomes for our event A, and we're going to divide it by all possible outcomes, which is our sample space, U. So for example, if we were looking at rolling a 6-sided die, and we wanted to look at what is the probability of rolling a 4. Well, on a 6-sided die, there's only one 4 on there, so that would be our favorable outcome. And all of the possibilities of rolling a number on a 6-sided die is 1, 2, 3, 4, 5, and 6. So we've got 6 outcomes. So the probability of rolling a 4 is 1 out of 6, or 1 over 6. Another common example might be using a deck of cards. So let's say we're looking at the probability of pulling a queen out of the deck of cards. Now, you've got 52 cards in a deck, you've got 4 different suits, and in each suit, your spades, clubs, hearts, and diamonds, you have a queen. So we have 4 queens in the entire deck of 52 cards. So the probability of this would be 1 out of 13, just simplifying the fraction. All right, so that's theoretical probability. That's the type of probability that you could reason out or you could talk about based on on doing a lot of trials. If we did this over and over and over and over and over and over and over again, then we would come up to these numbers. We may not always pull a 4. We may not always roll we may not always roll a 4. We may not always pull a queen, but the probability of doing so is going to roughly be the same any given time, as long as those all 6 sides are even, or all 6 sides are your standard die, or all 52 cards are in your deck. Okay, so then the other type of probability that we have is called experimental probability. And experimental probability is a little different from theoretical probability, because experimental probability is when the outcomes are not equal, or equally likely to happen. So we don't know what the outcomes are going to be just from looking at the situation, right? We can't analyze it from looking at the situation. So what often happens is we have to do some kind of testing and observing to see what the outcomes are like. All right, so that way we can find our generally what we have to do to get that experimental probability. So let's look at an example for an experimental probability, okay? So if we are looking at experimental probability and we want to look at a situation where we want to observe the colors of cars that are coming or passing in front of your school in the morning, okay? So you could list this out in any way. We're going to just list the colors that we have here. So we have the colors and then the frequency of each car that passed. So let's say we've got red and black and white, green, blue, gray, and everything else. Okay, we'll put it all together. And let's say we went through the process of actually observing all of these things. And we found that we had 14, 16, 2, 14, 17, 23, 21. Right? All of these different things happened this amount of time. So these are not the probabilities. This is just how many red cars we saw that passed in front of the school in the morning, how many black cars we saw pass in front of the school in the morning, how many white cars, and so on. Okay? So what do we have to do to find the probability of a red car that passes in front of the school in the morning? Well, we said we had to count the number of favorable outcomes, so that would be how many red cars pass by, over the total sample space, which is the total number of cars that pass by. So we have to first find the total value. So we have to add up all of these frequencies, the 45, 16, 2, and so on, and we get 138. Okay, so we add all of that up. So now the probability is the favorable outcome. So what's favorable here is getting a red car. So we're going to have 45 over 138, right? And that's a roughly 0.348. I did some rounding there, so maybe 35% chance of a red car passing in front of the school in the morning. So what if we then observed for the entire day, we just had someone out there counting the number of cars that passed by all day long, and there's 350 cars that passed in front of the school. So how many were red? Well, if we didn't count specifically how many were red, we could come up with the probability, or using the probability that we've observed in our experiment, we could estimate how many cars there would be. So assuming this same pattern happened of 45 cars, red cars, 16 black cars, 2 white cars, and so on, assuming that same pattern would continue throughout the entire day, we would take our 45 over 138, right, the probability of our red, and we would multiply it by how many cars passed. So we're going to multiply it by 350, and we get a value of 114. So we would expect, if this was the way that this happened all of the time, we would expect 114 red cars. Now, of course, this is just probability, right? We can't guarantee that we will always have 45 red cars pass in the morning and that there will always be 114 red cars that pass through the entire day. But based on this one day of observing, we could come up with this estimate. Now, of course, if we wanted it to be more accurate, we'd have to observe this over time and maybe like a week or a month, and then get our frequencies and then do our calculations. But if we just had to do it really quickly, here's one way that we could come up with our probability. So hopefully that helps get some of the definitions laid out, and we'll look at other ways that we can analyze probability in other videos. Talk to you soon.